Alright, hey guys, what's going on? So today we are going to be talking about the external pullback in quantum gravity. Specifically, we're sort of going to be alluding to a canonical momentum. So we're going to start off by picking up where we left off. I realize it's been a while. Things have been a little bit busy on my end, but we're going to pick a few things back up. I'm going to be focusing a little bit more on quantum gravity, and then I'll start switching back and forth again between general relativity and quantum gravity. And I also have some other ideas that I want to start as well. So with that being said, make sure to hit that like and subscribe button. Make sure to go onto my Patreon page if you want to support the channel, or become a member if you want to see these videos in full. Okay, so what I've been posting that you've been able to watch are the videos that are free, and it's not the entire video, right? So if you become a member, or if you go into my Patreon account or my Patreon page, you will be able to get the full video and not just the free version. Right, so let's get started. So we're now going to really investigate this action. In doing this, we're going to see that we start to get a defined Lagrangian density for our quantum theory of gravity. Once we have the Lagrangian, then we'll be able to have this quantum field theory of gravity, and we'll be able to understand a Hamiltonian theory of gravity also. So this was the action we sort of left off with. And looking at this looks a lot like a momentum term multiplied by a derivative term, like this, right? So we have some p, perhaps this thing here, and then derivative, we have a Lie derivative, and this thing, okay? That's all fine and good. And then this part here looks an awful lot like two momentum terms plus a potential term. That's similar to what we see in quantum physics, right? So in quantum physics, right, we have a momentum squared, right? So we have these E tildes, okay? So these things might be akin to the momentum, or the canonical momentum. And then we have this big giant thing over here that might be related to some potential. And we'll see when we condense this down even more, we'll be able to see what exactly is the canonical momenta, what exactly is the canonical variable here. And then we'll really be able to understand what quantum gravity is in these terms. So we also notice these superscripted 4s, right? So this was not in our earlier video. This really it just refers to the curvature tensor in four-dimensional space, right? So when we have this 4 here, these 4s, right? So we have them here, we have here also. This is really referring to x, y, z, and time, okay? But we can ignore all these terms for the following reason. And we're going to go, or not all these terms, we can ignore all these superscripted 4s for the following reason. So we're going to go ahead and do that now. Before we do that, let's go ahead and first establish two things. One is we can rewrite this guy here to be just one of these, right? So recall that these q's are the spatial part of the metric, right? So when we're talking about the metric g mu nu, when we did this when we talked about the ADM formalism, we had all these terms. We had temporal terms. So these are all the temporal terms, and then all the spatial terms were in here. Okay, and so these are the spatial terms, and we were able to show that the spatial terms can be written in this way. This is the normal vector to our manifold, and so when we multiply everything out, we get this, and then this guy stays. Right, so these two guys stay. We can add these two guys together. We get this, and then this becomes this because we're summing over C, and then here we get this term and this term, and then we can see here that this is just a redefinition of this. And because Q is purely a spatial metric, the time derivative of a spatial metric, that's something that has no time component in it, is going to be 0. All right, so now let's use these two identities to externally pull back from the 4-dimensional space to the 3-dimensional space. Right, so we're pulling back, we're splitting time and space apart, and so let's go ahead and get to this, right? So this term here, we want to get rid of this 4, right? So we have this term. Well, that's equal to this, right? Hey guys, what's going on? If you're interested in this video and want to learn more about loop quantum gravity, string theory, and so forth, what you can do is you can become a member of this channel and you can gain access to all the videos that become uploaded on this topic and future topics as well. Again, thank you so much for your support and thank you so much for watching. This channel keeps on growing and growing, and I'm very excited to see where this is going to go in the future. So with that being said, make sure to hit that like and subscribe button if you like this kind of content. Make sure to become a member as well. Thank you, and bye.